today I'm here to talk to you about how we scale up and manage 1 billion transactions on Black Friday. So a bit about me, probably if you came to my previous talk, you'll know all this, but started in mainframes, went on to web application servers, worked on JVMs, then started doing more developer relations stuff, talked about open source security for quite a while, and now I'm in a front-end role, which is very interesting, so totally learning something completely new. Today, the agenda, first of all, we're going to look at what Black Friday is and the madness that Black Friday is and Cyber Monday. I'm going to talk about who we are, just because that'll give you some context into why we have to scale up over Black Friday, how we're going about closing down our physical on-premise data centers, the preparations that we go through for Black Friday, the technology that we use that keeps everything running smoothly, some issues we've had in the past. We've actually had complete blackouts, ironically, on Black Friday, and basically how we resolve those, what the future of our tech stack is going to look like, and then some useful resources, and then any questions at the end. So the madness that is Black Friday. Is Black Friday a thing here? Yeah? Oh, I'm sorry. The Americans like shipping stuff over that we don't like, don't they? Yeah. I went to the Orion Mall the other day, and you've got more American things than we do. There's a Taco Bell. I was like, we don't even have all that stuff. So, yeah, I apologize. But yeah, a brief history of Black Friday. So this actually started in 1869. This was actually a financial crisis in the US that basically affected gold prices. That's why they called it Black Friday. Fast forward quite a few years, retail started using this term because basically after Thanksgiving, none of the workforce was showing up for work, right? So the retailers then called this Black Friday because half of their staff were ill, okay? And then later on, the Philadelphia police actually used the term because of the chaos on the roads. Now it's kind of solidified in the 1980s into the term we use today. This was basically the unofficial start of the Christmas shopping period when retailers would go from in the red, so making a loss, to in the black, making a profit, right? Luckily, a lot of the Black Friday stuff now, we all do it online, right? But when this phenomenon came over from the US to the UK, it was quite normal to see scenes like this, people camping out stores ready to rush in. But yeah, thankfully it's all online now. But that leads us to what we have to deal with. So the 2024 numbers are pretty similar. Still waiting to get them, but around 1 billion transactions, right? So we do 340 million on Black Friday. We do a few more, 262 on Saturday. And then Cyber Monday comes, and then we've got to deal with lots of more transactions, right? So it's about double the traffic compared to what we normally have. So quite a lot. It's a 70% increase on average across all our services. So how do we manage this? Well, yeah, like I said, unfortunately, it's one of those things that the Americans have shipped over to us, like McDonald's and KFC and all that rubbish. But yeah, it's a lot of preparation goes into this, right? We monitor it at different times of the day. America used to be the busiest amount of traffic. Now Europe, which is annoying. We actually see more traffic on Black Friday in Europe. And we've also seen it starting to creep into Asia as well, right? So this is going all over the world. So the era of the cloud, right? Most of us are using the cloud these days. We don't use physical data centers. As the company I work for is over 30 years old, we do still have physical data centers that we own and we run our stuff on, right? But we're in the process of shutting those down and moving everything to the cloud. So what does the cloud essentially offer us, right? So this is, say, a normal data center. Of course, I have to have the hardware to deal with these peaks, right? So essentially, I'm having to pay and run hardware at 2 times our normal capacity because on Friday, that's what we're going to have to deal with. So moving to the clouds, it gives us a bit more granularity. We can scale down so we don't have to pay for the red blocks now, right? But ideally, what we want is microservices. This makes it even cheaper for us and enables us to scale at better cost, right? Now, a lot of people don't think about this, but money equals energy on the cloud, right? So the more money we're spending on the cloud, the more energy we're using. I think I saw a report a few years ago which basically said that in the next 10 years, something like 1/5 of all energy in the world is going to be going to data centers. We don't see this, right? We don't see these data centers. We're happy to use our phone. We're happy to shop. We're happy to use all these beautiful services. But that costs a lot of money and a lot of energy, right? I don't know if any of you ever saw, Microsoft were actually putting data centers in the ocean around Scotland, which was pretty cool. I don't see how that's going to help with the oceans warming, right? If we stop putting all our data centers in the water. But yeah, it's a big concern, and we have to be conscious of how much energy we're using. Now, microservices are great, but they add a hell of a lot of complexity, right? And then we have to think about a lot more things that we didn't before. So they have to be robust, they have to be observable, scalable, resilient. We need them to start up quickly, right? So if you're developing on the cloud, which I presume most of you are, there's this really good thing called the 12-factor app methodology, right? This kind of declares the main things that we should be thinking about when we're developing on the cloud. So where we're storing our code base, what are we doing with those dependencies we're using, right? Because we shouldn't be just pulling down dependencies from Maven Central and putting them in. We've got to think about the security sides of those. Configuration. We don't want to be configuring our applications inside the code, right? We want to externalize that. Any backing services we have to consider, how we go about building, running, releasing our services, any processes that are involved, how we bind ports, concurrency is a big thing, disposability, how we throw away our stuff, how we kind of mimic the cloud environment on our local machines. So if any of you have ever used test containers, that is a really great way of trying to essentially bring your production environment down onto your machines, because how many times have we heard it works on my machine and then we ship it to production, it doesn't, right? Logs, what do we do with logs? We need to do something with those, and any of the admin processes involved. Now, this was created quite a few years ago, so they've kind of redesigned this, and of course, it's now 15 factors, right? Of course it is. So the main three things they added here was API first. So if you're developing microservices and you've got lots of teams working on lots of different microservices, what essentially we want is to be allowing each team to know how to interact. So Open API, Swagger API things are really good for this, because it means another team that's developing another service that has to interact with mine knows what to expect from the API endpoints. Telemetry is really important on the cloud as well, because we need to be monitoring all these services to make sure they're healthy. And authentication and authorization is essentially security, right? We're all aware of things like the Log4j vulnerability that happened, maybe because it wasn't in the 12 factors originally, no. But we do need to be conscious of the things we're downloading from the internet, which is weird because I've never worked for a company like the one I do now, because we do also identity and fraud solutions. Our security is crazy. Like, I can't pull anything from the internet. I can't even get on half of the websites. I've never ever worked for a company that actually did this correctly. I've worked for a lot of companies that essentially, they just allow you to download and pull anything onto your machine, which is not too bad in Java, because Java we have, you have to own the namespace to put something on Maven Central, but things like Python and Node, etc., they are full of malware. So we've got to be very cautious what we download and put into our applications. So mapping all this stuff, it looks a bit like this, not very nice, but again, all these things we kind of have to consider, right? And again, we have to always be prepared that they need to be rapid, scalable, loosely coupled, observable, all these good things. Now, the problem is when you try and do something like improve the startup time, it has detrimental effects on some of the other things, right? So me basically making my startup really quick might mean that it doesn't have good response time, or it might not have the right throughput. So we have to kind of weigh up what we want to do and what we're trying to achieve, okay? So an introduction to who Locate are, to give you context of why we manage lots of transactions. So we have the biggest address database in the world, right? Lots of the biggest companies users, Microsoft, Oracle. We've just signed a really big contract with, I won't say who yet, but basically one of the biggest delivery companies in the world. So we, on Black Friday, when people are shopping, etc., and they're searching for their address, that's when our throughput goes through the roof. We've also got stuff like Verify that makes sure that the address that's inputted is correct, and stuff like validation for phone, emails, and banks and stuff. So now you know what we do. Now you can see why we have lots of traffic on Black Friday. Now, what are the preparations we go through? Now, this starts about 3 months in advance of Black Friday, right? So we start preparations 3 months in advance, then we do more a couple of weeks before, and then there's a few final things we do up to the last few days. So in the first 1 to 3 months, what do? So we generally see double the traffic, right? We have 3 data centers currently. And what we want to do is we do testing for essentially if one of those data centers goes down, we need to make sure the other data centers have the capacity requirements to keep serving traffic, right? So we do a lot of platform load testing to basically check the stability of the infrastructure we're using. We then do product load testing. So we do 6 times this, because that means if one of our data falls over and the traffic reroutes, it means we still got double the capacity we need, right? And the support team. So my advice generally, if you're doing platform testing and if you're doing product load testing on production, which is what we do, it's probably best to notify your customers, not that there's going to be downtime, but that there might be some latency issues over this period, right? It's better to let them know rather than if we break stuff, it goes wrong and then they're all shouting at us. So 1 to 2 weeks before, this is when we start scaling stuff up. So we scale up our legacy VMs because they're a lot harder to scale automatically. So we scale up our servers. These are the stuff on the cloud. So we look at the performance testing we've done before, and then we decide if we need to scale up our on-prem data center stuff, because that is a lot harder to do and a lot more costly. Then we generally scale stuff down probably about mid-December, so after it's all over. And again, we notify our customers if there's any outages that might occur. Now, 1 to 2 days before, we basically do the testing. So we basically knock out one of the data centers, usually the US one, and just to see if all the traffic can reroute to another one, right? What I advise is disable non-essential jobs if you've got a particularly busy period. So database maintenance, that stops. We stop a lot of the reporting. We basically stop a lot of the usage service as well, and basically don't do any server patching, please, if it's a busy period. We disable updates to our data because, of course, we're constantly adding more addresses to our data. We do that pretty much every day. So we disable that over that period. And again, it's very important that support knows what's going on, right? So what we do is we increase the number of people in support, and we also put the engineering team on high alert, right? So they're there ready, that if something breaks, they're ready to fix it. So where are we with our stack, right? Well, we're kind of in the middle of between here and here, right? We've got a lot of legacy stuff hanging around because we're an old company. So we use a mixture of virtual machines and Kubernetes, right? That's useful for us because we've seen in the past with some of the Kubernetes services on some of the clouds that have gone down. So a lot of the VMs are there because of the legacy services, but having VMs and having the ability to spin up VMs allows us to fall over if there's ever a problem with the Kubernetes service, right? So this gives us reliability, failover, scalability, and it helps with cost a little bit. So supporting services, we use stuff like Google PubSub because, again, everything we run is on Google Cloud. Only the big customers like Oracle, IBM, and Microsoft, they run stuff in their own data centers. But for us, we run everything pretty much on Google. The only instance of AWS we use is Nike. I don't know why Nike were very adamant we use AWS. But yes, we generally use Google PubSub, BigQuery for searching for the data, and then we use all the Google Cloud monitoring and logging services. So yeah, due to the acquisition of lots of other products and some of our legacy stuff, we essentially have a mixture of the two. So we have some microservices and we also have monoliths. So what is it? It's a free tier web application. Funny enough, the main monolith is called services, which was very confusing when I first started. That doesn't help. We're trying to break services up into lots of pieces, but currently all of our traffic goes through this services service. It's backed by a web database, but we're slowly transitioning to MongoDB, and we inserted a PubSub queue to help stop servers crashing under load. So traffic balancing. So like I said, last minute, we tend to take one of the data centers offline. All of our data is location-based. So if you're in the US, it'll go to a US data center. If you're in Europe, it'll go to our UK data center. And so taking one of them offline is quite important. We have 24-year-old services that have never been shut down, right? Problem is 10,000 of our customers are self-serve customers. So they're small retailers that employed a developer to build their website 25 years ago, 20 years ago, 10 years ago. They don't have the developers or the experience to move to new services, right? So how we do releases is we'll generally release a new version of the API and move the URL. But the problem is we have no contact with these customers because they're all self-service. Yes, we've got some email addresses assigned to the account, but most of them, a lot of the emails just bounce, but they're still using our services. So it's very, very difficult for us to shut down these things, okay? So issues we've had in the past. We actually had a massive outage on Black Friday, which was, as you can imagine, our customers were not very happy. There's been a few of these over the years. We've addressed a lot of these things by adding automation to the web layer, which has allowed us to scale a bit easier. We've also done a lot of work to decouple the elements. So like I said, we're trying to break stuff apart and put them into microservices. We've also added a caching layer, which helps basically between the web servers and the SQL. So what happened for us to have this big outage? So the last outage we had was 2020, obviously learned from that. So basically our on-site data center somewhere, I think it's in Arizona or somewhere like that, it crashed. It completely went offline, okay? All of the US traffic then got routed to Europe. Of course, the European data center, the firewall went, whoa, what's going on here? That's not correct. And it blocked everything. So not only the US customers got blocked, but all the European customers and all the Asian customers as well, which was very annoying. So moving to the clouds helped with a lot of this. We still do have a few data centers. They should be on-prem data centers, but they should be shut down this year. So adding in more automation and a more advanced firewall has helped solve this problem. So the future, what are we planning to do, right? So we're doing work to improve the scaling. Obviously, it's hard when you've got big services, right? Our services used to take 10 minutes to scale up, right? That's no good because within few minutes, we can see a massive surge in traffic. So we're trying to remove some of the manual elements. We're moving more, like I said, to a microservice-based architecture. It helps us to scale. So our microservices come up in less than a minute now, as opposed to like 10 minutes. And a lot better monitoring, okay? So if something does go wrong, we can react better. Also, we've put manual scaling into the configuration. So rather than someone having to go into Google Cloud and scale stuff up a few days before, we can just put that into configuration and say, look, on this date and this time, we want you to scale up because we're probably going to see a lot more traffic. Geo-distribution of our data centers is more important, so bringing more of those online. Better capacity spreading across the data centers, because currently all the Asia traffic goes through the US. So it's enabled us to scale better and distribute the traffic. And also multi-cloud is something I'm very passionate about. I think if you put all your eggs in one basket, so to speak, and you're using just one cloud provider, they can keep hiking the prices up. And if you're using that cloud provider's services, it's very, very hard to break away and move to a different cloud provider. So some of the work we're doing this year is to have it so our traffic is distributed between AWS, for example, and Google Cloud. So what's the plan for our data centers? So currently we have 3 data centers, one in mainland Europe, one in the UK, and one in center of America. So we want to bring a new US data center online. So on the West Coast, that will help with latency in America. We want to bring a data center online in Asia, but what we've discovered is Google have a service where you can use the backbone fiber from Google, which is really cool. Essentially, what it allows us to do is basically avoid all the other routes that data traffic has to go through and use Google's backbone. The latency is really, really good. Of course, you have to pay for this service, but it basically has enabled us, it's bought us more time before we have to bring an Asia data center online. So that is pretty cool. So if you're curious, have a look on Google. You can actually pay to use their backbone, and the latency is really, really impressive. So reducing cloud costs. I think we spend about $250,000 a month on Google Clouds. That creeps up to $300,000 per month. So over the last quarter, there's been work to bring the cost down, and we've done so. We've got it back down to $250,000 a month, right? So how have we done that? Automation, that saved quite a lot of money, and it's also helping us avoid outages, improving the service startup time, because the time it takes your services to come online and scale up, you're essentially spending money and it's not doing anything for you, right? So improving the startup time has helped bring our costs down. Moving from Windows. Windows is quite a heavy operating system. A lot of our VMs are all Windows, so moving to Linux, a nice lightweight version, has also helped to save quite a lot of money. Context Engine has helped quite a lot, and having backwards compatible services too. So to kind of conclude, takeaways, capacity testing is key. And I would say do it way ahead of time. Don't wait a few days before, just in case you hit some problems and you've got to do work to fix your capacity. Manually, if you know there's going to be a super busy time, manually scale up, right? Not all scaling services are perfect. And if you've got services that take a while to come online, it's definitely worth to manually scale stuff up before. And I would also say notify your users when you're testing manually. We hired a really good platform engineer about a year ago. He is amazing. He's basically rewriting the whole platform. His knowledge about Kubernetes, how Google Cloud works, etc. He is phenomenal. Whereas before, it was mostly the devs trying to do that. As a result of the devs doing that, we have some crazy architecture, right? So it's better to employ someone who knows how to do this stuff rather than relying on your developers. I wanted to show you an architecture diagram, but it was so crazy. I was like, yeah, I can't show you guys that. So I left it out of this presentation. But a good platform engineer can help resolve those issues. And the earlier you hire one, the less likely you are to make bad architectural decisions and easier going forward, right? And make sure you keep all stakeholders in the loop. Customers, keep support in the loop, keep your testing engineers in the loop. Just try and keep, and your devs, right? So just try and keep everyone in the loop so they know what's going on. And automation, like I said, is key. Automation's helped to save a lot of money. It's helped us avoid essentially blackouts, but don't just purely rely on that. Not all the clouds are perfect, right? They do have issues, so it's best if you don't fully rely on automation, but use it where possible, right? There's some information here from what I've talked about on these links, so feel free to go and look at some of that stuff. Feel free to get in touch with me. I don't use Twitter so much anymore, but I'm available on LinkedIn if you want to have a chat. Thank you, everybody. I hope you enjoyed the talk and enjoy the rest of the conference.